Hi, everyone. Welcome to this webinar entitled Small System, Big Impact, How Santa Clara, Utah Achieved Exceptional Water Loss Reduction During Drought. I am Mandy Crispin, Editor-in-Chief of Water World. Let me explain how you can participate today. First, if you have any technical difficulties, please submit feedback to the questions window and our experts will help you. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but you are encouraged to send your questions at any time. To do so, simply type your question into the question window on the side of your screen and hit the submit button. Also, please be aware today's session is being recorded and will be available within the next week. You'll be notified by email when the archive is available. Now I would like to introduce our speakers for today's discussion. Cesar Garcia is a territory sales manager for ASTERRA, an infrastructure intelligence company supporting water utilities in their efforts to conserve resources, reduce non-revenue water, and strengthen long-term system resilience. In his role, Cesar collaborates with partners and utilities across the Western United States, helping them harness advanced satellite technology, transform their operations, and achieve their goals. And Jacob LeBrand is a senior water asset management technician with McKim and Creed, bringing over 8 years of experience in water utility services, leak detection, and flow analysis. He supports field investigations by assisting with daily leak detection activities, including pipeline inspection, identification of potential leak areas, and confirmation of leak locations to assess non-revenue water impacts. Jacob is OSHA safety trained and holds multiple industry certifications. And unfortunately, Casey Stratton, Director of Public Works at City of Santa Clara, couldn't join us today, so we're going to go ahead and proceed without him. Welcome, Cesar and Jacob, and you may go ahead whenever you are ready.
Thank you, Mandy. Appreciate your introduction there. So today, folks, we'll be talking about the city of Santa Clara in Utah and how their water utility used advanced satellite technology and AI to reduce real water loss to save money, save water, and to increase their drought resilience. We're also going to be hearing about this advanced technology, how it can be combined with the traditional leak detection methods and to increase the efficiency. Next slide, please. Now let's talk a little bit about the city of Santa Clara. It's a fairly small system, but their goals are big, which are to reduce real water loss. And this project actually was initiated in 2026. They have a population of 7,500. The desert climate, low precipitation, and with the utility goals that they're looking to reach were, like I just mentioned, reduce real water loss, leverage innovative technology like ours, and with that combined would be to reach the goal to increase their drought resilience. Next page, please. Now, what we have here right now is how it is that we use this technology to help utilities to find non-visible leaks. What we use is the L-band, the synthetic aperture radar, with infrastructure intelligence. By using the satellite, we're able to cover a large area. What you see here on the left side of the screen, it's an image of San Francisco and the Bay Area. As you can see, multiple municipalities or cities can fit within one image. Now, by using the sensor, the L-band, we're able to penetrate the ground up to 10 feet, depending on the type of soil Now we can also penetrate through cover forest. We can penetrate snow, concrete, asphalt. At the moment, we can't penetrate is metal. Now, once we collect the data that is given to us through our algorithm and our AI, we're able to show within your GIS map where there is locations of potential soil moisture of potable water that accumulates around the pipe systems. Now, next, I would like to pass the word over to Jacob, and we want to get into how it is by using our technology, they're able to become more efficient when they're out in the field. Jacob,
Hey,
the word
thanks,
is all
Caesar.
yours.
I appreciate it, man. So at McKim & Creed, we're one of the leak detection companies that ASTERRA uses for the on-the-ground studies after the satellite images have been taken. We were the boots on ground for the one here in Santa Clara, and I just wanted to kind of go through a few of the things that we do. We utilize the satellite imagery and the ASTERRA points of interest to be able to narrow down where leaks possibly could be and will be. Once we have those areas and we import them into our system, we go in and survey within the area. It's usually about 500 feet to 1,500 feet, depending on the area. We usually try to work a little bit outside of those areas as well, go about 3 or 4 connections outside of them. And what we do is we walk through with acoustic equipment and we try to sound every connection possible within that area. Once we've identified some leak noise, we start to try to narrow that down and try to pinpoint any leaks that are inside that area. Also, if we hear any noise that's outside of the area, because what's happening with these zones is they're being placed there as water that's settling. And so the leaks could actually be outside the area. So you use the topography, you can go uphill outside the area to try and see what might be leaking into it. Once we've identified all of the leaks, we go through and log in all of those things into the ASTERRA platform as well as ours. And then those get turned over to the client for repairs and reports. It really helps us working with ASTERRA because it narrows down where we have to work. Usually we're working like a mileage contract or a daily rate contract. And really it's about, can we get through the whole system? And it's going to take us a lot longer. And it's also, we're going to have probably some days where we're not really finding a whole lot as we start working through the entire system. With ASTERRA, they put us pretty much right on the dot. And we've had a pretty darn good success rate with their ASTERRA POIs. Really, the deciding factor here in Santa Clara, honestly, was the willingness of the utility to come out and help. As sad as it sounds, there are some utilities out there that haven't really gained an appreciation for the non-revenue water aspect of the industry. And they might be bringing us out just to satisfy a state requirement or something like that. And you pretty much get left in the dust trying to figure out things without a whole lot of information. We always say the more information we can have, the better. We're only visiting these water systems, but if we can have a utility personnel or just a utility in general that has good GIS, good data, and is willing to pass on that information, it helps tremendously with our results. You can go ahead and pass it to the next slide if you don't mind.
Just real quick, Jacob. I wanted to ask you something. And I mean, I've been out in the field with a few of you guys, and I've noticed that when you guys are trying to pinpoint the actual leak itself within our point of interest, you tend to use these different traditional method of of different devices, correlators, and listening devices.
Yeah,
Uh,
absolutely.
mhm. Tell me a little bit about that. How it is that by using those devices and with the Stera together, you're able to pinpoint and give the utility that exact point with the mark on the ground to go and repair those leaks.
Yeah, absolutely. So we're going into those areas and using sounding gear. My personal equipment that I generally use is FCS. We use the DX mic and the B mic. Um, I also use the Ovaro Enigma correlators. Those are post-time correlators, and those tend to yield the best results. We usually start by using what I usually refer to as the probing rod. It's just a stick attached to the DX mic where I can touch any asset that's in the system and get noise off of it. Then once we start getting into the pinpoint process, I'll break out the ground mic depending on where we are. Usually those work a lot better over pavement or solid ground. When you can't create that seal with the ground mic, it tends to um, get a little funky. But in those situations, we just continue to use the probe over the ground. Usually, as long as you can get half an inch deep or so, you can hear
Mhm.
pretty far down. I'd say probably about 6 to 7 feet. Beyond that, you might need to use another probing rod to get in, but um, if we're working on metal, noise travels a lot better. Um, so we'll utilize the correlators once we start hearing some noise to try and narrow that down instead of wasting a
Mhm.
bunch of time just kind of hunting and pecking everywhere when everything sounds the same.
Yeah.
Those correlators will place us on a leak. They're usually pretty good. When they're not good, it means our data is not correct. So that's just something that we have to fix on the back end. But they'll put us within, we call it the 10% rule. So if you've got 100-foot correlation, it's going to put us within 10 feet. Usually it's a lot more accurate than just that 10%, but that's something to keep in mind when using them.
And when using Astera with these traditional methods, and I know with the we're going to go into the numbers right now here in a
Mhm.
second, but with you being out in the field, what is the main benefit that you see by using Astera, the traditional methods to help the utilities?
It's certainly a time thing. So time and effort really in general. So if we're going in on a mileage contract off of just like a McKim Creed project, we're going in and we're trying to survey, 100, 200 miles of pipe. That pipe is just, it's either the entire system or some bigger systems like to do chunks every year. And so you're just going in basically blind. You're trying to sound everything you can. You use different methodologies depending on the type of pipe you're working with, depending on the amount of pressure on the pipe. There's a lot of factors that go into how you want to tackle a project. But with Astera, we get placed in specific areas where a leakage is likely present instead of just kind of hunting, pecking through the system. So I would say probably the biggest thing is time.
Understood. Nice. Thank you for that. I hope the audience got a good feel of the of that value of
Yeah.
Astera. But let's go ahead and go to the next page, and I'll let you go ahead and do your talk there.
Yeah, so this was a 5-day project for Santa Clara. They contracted Astera to get the scans done and then brought us in on the back end through Astera to do 5 days of leak detection. Over those 5 days, we found 48 leaks. I believe there were 18 points of interest that were identified in the small system, which is a crazy number that we came up with. 16 of those were utility side, 32 were customer side. Um, a rough estimate, I want to say 8 to 10 of those customer leaks were identified as not registering on the meter. So those are just as good as finding a distribution leak. Really, again, it's the time thing, right? We could have come in here to the Santa Clara system, and it probably would have taken us, because of the layout of the system and how hilly it is. It definitely could have taken us upwards of 4 weeks just to cover the entire system, maybe even 5 to 6, with it mostly being PVC. With ASTERRA, we were able to come in a week and drastically drop some of their non-revenue water. And I'll pass it back over to Caesar to go into some more in-depth stuff when it comes to the numbers, because I'm not very good with those.
No worries. But thank you for that. And so when it comes to the benchmarking, we've noticed that in this particular project, that the U.S. average is 1.3 leaks per day. We have 3 leaks per miles. And in Santa Clara, if you see there on the presentation, you can see with the ASTERRA, the numbers went up quite a bit. So, and that's like, it goes back to what Jacob was saying, that our primary goal is to help you to find those leaks a lot faster, being able to get to them, to repair them. And by doing a continuous monitoring, which we suggest to most of the utilities, which would be multiple scans, we're able to even to raise those numbers, right? Where you're seeing even more leaks found per day and per mile. So in the end, with the real water loss identified, 50 million gallons per year are being saved with these methods. If we start looking at different other utilities that we help out, which is all around the world, but our numbers keep increasing every day. We just hit a milestone of 200,000 verified leaks since we were commercialized last week, which we're really proud of. But yeah, but with this particular utility, they were able to see the benefits, and we're extremely happy that they gave us the opportunity to do so. So even though it's a small system, but small, medium, or large, right now with the drought issue we're having mostly in the West Coast, every drop counts. And I hear this in all the conversations I'm having lately with these different utilities. They tell me, even though they have a decent non-revenue percentage of water being lost, that they still consider even 1 or 2% valuable, and when it comes to the money and the savings, and more than anything, the conservation of the water itself. Let's go ahead and go to the next slide, please. So in conclusion, it's kind of a little bit what I was just saying. Smaller systems can achieve outsized impact when they combine advanced tools with strong operational partnerships, kind of like what Jacob was speaking of, and what we do with McKim-Creed and the utilities. Our satellite technology can significantly reduce real water loss in drought-stressed regions, strengthening the community's resilience during water scarcity, which is happening now. And finally, integration of advanced technology with traditional leak detection methods increase efficiency and accuracy. So not alone with the ASTERRA, do we say it's a solve all solution, but with this combination of methods of the top, I would say, acoustical teams that are out there, and we use one of them, McKim-Creed, we're able to truly show the value within our platform, discover these savings that we're just speaking of. So if anybody's interested, we'll go here to the next slide, and we'll have our information where you can reach out to us.
Okay, so thank you so much. All right, everyone, we're going to do some questions. So as a reminder, if you haven't got your question in yet, go ahead and type it into the questions window and hit submit. And let's see what we got here for you guys so far. Okay, so somebody wants to know, what is the timeline for the scan from ASTERRA? So I guess there's two questions in that one. So do you just scan one time, or is it continuous scanning? And then what's the timeline?
That's a great question. So the satellite takes about 7 to 14 days to orbit the planet. In the time that we receive the data, it takes us about 4 to 5 days to go through it and come up with the points of interest that we supply through our platform. So we're roughly looking at about 2 to 3 weeks for you guys to have your password and your login for the platform.
Okay, and then you would go ahead and facilitate a ground crew.
Yes, correct. So what we do, I mean, when we send the satellite out and we know the image the scan is being taken of the AUI, we start planning the boots on the ground team, the date they're going to go out there, as well as we do a kickoff call. We do a training of our platform and of our UCollect application that the boots on the ground team use to be able to see the map and where the points of interest are. But yeah, that's basically how that works, the process.
Okay. Great. Okay. Let's see. All right. This one I'm going to assume is for Jacob, but maybe Caesar has something to say about it. So this person wants to know, were these leaks identified for the customers before or after their meter?
Yeah, I'll take it. So anything that was labeled as a customer leak is going to be a leak that's beyond the customer meter. So not something that the utility is responsible for generally. Anything that is labeled as a distribution leak is basically on the curb stop and anything after the service line, main line, hydrants, valves, anything like that. So the way that we identify those customer leaks is generally by tracking it on the meter. If we are suspecting that there is a leak on the customer side that's not registering, we'll perform a shutoff right there at that curb stop or stop tap, however you want to terminology it. And once we complete that shutoff, we're able to track the noise and see if it goes away or see if it persists.
Gotcha. Okay. Yeah, because I know you mentioned that some of them were not registered. Some of the leaks were not registering on the meter. So that means the meter was running as though everything was fine, but you still found some problems, some issues.
Yes. So to follow up on that, basically in those situations, we were hearing leak noise at the meter. So on the curb stop. Once we detected noise, we tried to track it down following the service line. Once we started to not get any noise down the service line, we performed a shutoff to see if that meter was just not operating properly. Usually what's happening, I think actually in all of the cases in Santa Clara, it was all low flow. So some of the meters out there are 15 years old. Once you start to get up, you start to lose some of that low flow, like 0.08, 0.1 gallons per minute. So all of those customer leaks weren't necessarily large, but they're good to know. And that's good information to be able to extrapolate over the systems. Okay, we might be able to start doing like a meter replacement. That might be something that needs to be in the works in the next year or two.
Yeah. Okay. Something I hadn't considered. Okay, let's see. What is the success rate with C900 plastic water main?
Caesar can talk to the success rate on like actual their ASTERRA numbers probably. From our standpoint of acoustic, anything plastic, especially something like C900 or Schedule 40 pipe, is going to be more difficult. The noise just does not travel as far. That does not mean that we don't have success. We go into a lot of plastic systems and have a great success rate. Generally, you can still hear everything that's on the service lines, even if you're dealing with like a poly service line hooked up to that PVC. And then as long as the leak is a decent size, you should be able to hear it on nearby connections, or at least find signs that there's a leak going on, and you investigate further, even if that means probing on top of the line or deploying the ground mic to see if you can hear anything.
Okay. All right, let's ask another materials question since we're on the topic already. Someone wants to know, do you have any difficulty with asbestos cement when locating leaks?
Yeah, that's a tough one. Cement lines can be tricky. They're kind of in between your plastic and metal lines when it comes to how far noise travels. Really, the biggest problem that I find with cement lines is it can be tough to get it pinpointed within 3 to 4 feet, like we usually like to have it. Sometimes we just have to settle and say, hey, we know you have a leak here. This whole spot right here is just ripping noise, and end up asking the utility if we can be on site while they're digging it. We found some really good leaks on cement lines, but it is tricky. You definitely need somebody that knows what they're talking about.
Okay, and then I might as well go ahead and ask this again since we're on the topic. There's all different kinds of soil types. So does this work with all different soil types, or
It does.
one particularly difficult?
Yeah, it definitely works with all soil types. And like I said, the only thing we can't penetrate is metal. So, but also depending on the soil type is how deep we can go. So on average, we're able to see between 6 to 7 feet. But if let's say it's looser, we're able to go up to 10 feet. So, but yeah, but most pipe systems are 3 feet, 5 feet down. So we usually don't have a problem being able to detect that soil moisture that far.
Okay. All right. Have you done, or can you do, a rural water district that covers more than one county?
Yes. Actually, we have quite a few projects where we do that. We have right now a state project with New Mexico, and it's a lot of small municipalities, and we're doing a few large scans where they all fit in. So that is not a problem at all.
Okay. Yeah, I
It's
remember
actually
that
nice
first.
to see municipalities getting together,
Yeah.
and joining in the efforts.
Yeah. Okay, let's see. So this is a really good question. How does the scanning technology eliminate water from irrigation of landscaping or lawns, or does the scan indicate presence of water at specific depth ranges?
So when it comes to detecting the soil moisture, the algorithm is set to only look for potable water when what it's looking for is a conductivity. So each water type has a certain dielectric. For instance, potable water, you have the dielectric of an average around 81, but they also have the chlorine mix within it, and that's what the algorithm is looking for. So everything else is noise, as long as the potable water is touching the soil for a point, I think it's a 0.5 gallons per minute for more than 72 hours, we will detect it. Most of the lawns, when they're being irrigated, they usually evaporate by that time. So we haven't had a real issue with that. But if we get into these cities or these rural areas that tend to water their lawn all day long, sometimes we'll run into that some false positives, but that's rare. And what we usually do with the client is we coordinate the scan. So when it's we're doing that a little, when the client themselves, the water user, is using less irrigation on the lawns, we plan during the time of the year to send the scan.
Okay. Now, someone wants to know if their own staff can handle the boots on the ground work.
Typically, what we do is on the first go around. So we have a package called Prevent. It's 2 scans per year, right? So the first scan, it's pretty much mandatory that we send our boots on the ground team to do the first 5 days. Now, once those 5 days are up, and if your team is out there shadowing, or like somebody like Jake, and learning the best practices on how to use ASTERRA with your own equipment, yes, you're more than welcome to go inspect your own points of interest. Obviously, we're gonna keep a close eye on it, and we'll be there to kind of hold your hand through the whole process and make sure it's being done right. But to answer the question, yes, you can do it as long as you're able to understand our technology and use it as best as you can.
Okay. Okay, so we have a couple more questions. So if anybody out there has more questions that you haven't submit yet, go ahead. All right, let's see. So is it normal to find more customer side leaks than distribution side leaks?
That varies. Usually it's more the service and the mains that we see. Customer side leaks, they do tend to come up because our algorithm is looking for all potable water leaks, whether it be on their side or on the system side, on the utility side. But you're finding way more leaks on the utility side than on the customer side. And within the platform, it'll show you that. I mean, each time you go out and you inspect and you input the information on the UCollect, our application that's connected to the platform, you'll have those numbers in there showing you and the averages.
Now we have a couple of cost questions in here, and I'm going to assume that varies. It depends, right? That always depends. But we can probably answer this one. Is it an annual membership?
Yeah, it can be an annual or a multi-annual. It all depends on your budget. But okay, you can do one or in 2 or 3 years.
Okay, gotcha. All right. And then this one, how do you deal with acoustic noise and false positives? This has been an issue in past acoustic investigation projects, or at least for this audience member.
So I'll pass that to you, Jake.
Yeah. So a good bit of that comes down to experience and understanding what's going on around you. We definitely have a lot of situations where we have to go out at night to perform leak detection if the roads are too busy, or there's a lot of, say, high water usage businesses around, things like that. When it comes down to false positives, you don't run into those a ton, or at least I don't refer to them as false positives. Usually if you've got noise, something is using water or there's a leak somewhere. It's just trying to figure out why you're getting that noise. So that takes further diving into, instead of just saying, hey, got noise here, put a mark on the ground, let's move on. A lot of times it takes some more investigation to ensure that you're getting in the right spot. I mean, we've had multiple times throughout our company with some of our other guys and myself as well, where we've gotten kind of bitten in the butt a little bit, where you write up a leak, you think the noise is right there. It's a great noise on the ground. You dig it up and it's an old repair clamp. And then you move about 1,500 feet down the line, and that's where the actual leak is. So things like that will pop up, but a lot of that boils down to experience and honestly just kind of taking your lumps on them when you're in the industry.
Okay. As with anything else, right? All right. Okay, everybody, that's all the questions that we have for now. So if you have any questions, you can get a hold of ASTERRA. And on behalf of Waterworld, I'd like to thank Caesar and Jacob for speaking today. You guys did a great job. ASTERRA for sponsoring. And of course, as always, all of you for joining. And I'm wishing you a great rest of your day.
Thank you so much, Mandy. And thank you, everybody on the call. I really appreciate you guys attending.